Hello everyone, welcome back to my daily coding journey. So today I'm on day 36. I'm working through this neat code roadmap and I'm currently on graphs. Okay, so I have never read this problem before, graph valid tree. Okay. So given n nodes labeled from 0 to n minus 1 in a list of undirected edges, write a function to check whether these edges make up a valid tree. Okay, you can assume no duplicate edges will appear since all are undirected. 1, 0 is the same as 0, 1. Okay. Okay, so my understanding is a tree is a graph without cycles. And it has to be connected. Okay, so let's look at these examples and hope maybe that will illuminate additional information for me. So 0 is connected to 1, 0 is connected to 2, 0 is connected to 3, and 1 is connected to 4. Okay, so this is a valid tree. It's not a binary tree, but it is a valid tree. Okay, test case 2, we will do in blue. 0 is connected to 1, 1 is connected to 2, 2 is connected to 3. Probably shouldn't draw it so big, actually. Okay, so 0, 1, 2, 2 is connected to 3, 1 is connected to 3, 1 is connected to 4. Okay, so this is false because there exists a cycle. So what I'm thinking of doing is, and maybe I will later on see something that I'm missing. So I'm thinking of building adjacency lists, DFS through graph, starting at any position, and if we visit something in visited, then that means invalid. That means there's a cycle. So for instance, here we would do 0 and then 1, 2, 3, then we DFS from all of those. If we ever visit a node that we've already seen, then that means there's a cycle. Okay, and then lastly, I need to check that every node has been visited. So we can check if length of visited equals n. This also needs to be true because, for instance, what if we have an edge over here, 5, 6, right? This is not a valid tree because even if you got rid of this cycle here, this is not a valid tree because it is disconnected components. So I'm going to code that and see what problems we run into. Okay, so for edge in edges. Whoops, I'm on my Spanish keyboard. Okay, so for edge in edges. Let's make a adjacency list I'll call graph. So if edge 0 not in graph, then we'll say graph edge 0 equals empty list, and if edge of 1 not in graph, then graph of edge of 1. So it should actually be like this, like that. So edge of 0, if that's not in the graph, then make empty list, and same with edge of 1. Okay, and then we're going to do the two-way connection. So we'll say graph, and instead of doing this, I'm going to say node and connection equals edge. Okay, so actually I could just say that here. Okay, so if node is not in graph, then put it in the graph, just so we don't have to access the, we don't have to keep looking that up every time. Okay, so if node's not in graph, make an empty list, and if connection's not in graph, okay, and then we'll say graph of node dot append connection and graph of connection dot append node. Okay, so let me print graph and see if that's working as intended. So 0 is connected to 1, 2, 3, and 1 is connected to 0, 4, 2 is connected to 0, and 3 is connected to 0. Okay, so something I'm noticing is when we get to here, it has a neighbor 0. So I'm thinking what we could do is get rid of its parents, or just like if it's its parent, then we don't count that as something that we've already seen, because 0 will be invisited, of course. But we could say like, hey, if we see 0, even though it's invisited, it's also the parent, so like it's not invalid yet. Okay, so now we're going to DFS through the graph, and we can start at any node. So I'll just say, I guess we could start at node 0. So that will take in a node. And we'll have a visited set. Okay, so what we will say is for neighbor in graph of node, so these are all of its neighbors, if neighbor not invisited, then we will call it so DFS of neighbor, and then we'll say visited dot add neighbor. And here I'll just print. So I'm for those of you who watch my videos, you might know this, but so I'm more used to doing DFS in iteratively with a stack. So I'm just kind of playing around with doing it recursively. Okay, so we have a infinite loop. Maybe this is how I'm supposed to do it. Okay, so we visited 1, 0, or sorry, we visited 0, 1, 0, 2, 3, 4. So 0, 1, 0, 2, 3, 4. Okay, so the reason is visited must contain 0. Okay, so now it's 0, 1, 4, 2, 3. Perfect. Okay, so if it is invisited, then we want to print, well, so maybe every time we call a DFS, we should keep track of its parents. So we'll DFS with neighbor, and its parent will be node. So here I'll just say print cycle detected, and this will be wrong. So for this parent, I guess I could say -1. Okay, so when we get to 1, it's trying to go back to 0. So we want to say if neighbor does not equal parent. So if the neighbor is invisited and it doesn't equal parent. So no cycles. What about this one? Cycle. So we have 0, 1, 2, 3, and then we had a node somewhere else, right? 1 to 3. So then it'll visit 1 again. Okay, so we'll say else if neighbor does not equal parent. Okay, so here we'll return false, that it's not possible. And if we get to the base case, we'll return true. And then we'll return like that. So if I print this, cycle is true, that so this is actually does not have cycle. Or I guess I could say valid tree. Valid tree true, valid tree false. Okay. Also, another thing I want to check is, okay, so if this is a valid tree and length of visited equals n, then we'll return true, else we'll return false, like that. Let's see how that goes. Okay. It's saying that 0 is not in the graph. Okay, let me print out graph beforehand and see what is going wrong. Graph equals that. My output is false now. I'll also print out visited too. Actually, let's say not cycle. Okay, so I'll print graph here. Then I want visited after it gets updated from the DFS. Visited, and then let me print same thing with not cycle. And that's just a temporary name. Okay, not cycle is not defined. Cycle. I always spell that word wrong. Okay, so visited is only 0, 1, 4. Oh, because here it's returning true. So we have to go back. So I don't know when I would return true. I guess we could say if length of visited equals n, but then it's possible that we can never, yeah, so we're returning none. So I could have another set. 1 second. Okay, I'm back. So this is like the billionth time I've done a cycle check, and I still can't do it. Well, I'm getting better at it, but I know what we could do is we can remove visited here. I just forget. Okay, so my problem is I forget the condition when you return true. So instead, I guess I'll just make it a variable. So we'll assume that there is no cycle. And then if you get here, then cycle equals true. So this won't return anything. Okay, so instead we want to look at the variable cycle. Not cycle is not defined. Okay. Cycle equals false. Cycle equals true. Okay, so this works. I'll have to rewatch it again and see how to do it without using a global variable. Okay, so now we can detect a cycle. So if not cycle and length of visited equals n, return true. Let's see if this works. Okay, wrong answer. All right, so here we have no edges. So if we have no edges, I'm going to say that is not a valid tree. So if not edges, return false. Oh, it's actually true. Okay. So that is a valid tree. I guess it doesn't, it's just an empty tree. Okay, great. So this one is basically another cycle check. So I'm kind of realizing that it seems like a lot of graph problems involve doing a cycle check. So I'm kind of getting more familiar with it. I definitely should probably just memorize the algorithm at this point. I was able to build the adjacency list quickly, which is good. The parent thing kind of worked. I mean, this works. It's just the only thing is it uses a sort of a global variable. Or I have to increase the scope of cycle every call, I think is how it works. I'm not exactly sure what goes on under the hood there. Yeah, so this works, and thanks for watching.